What about the nursing
It has
entrance?
slope, like how to find the slope.
How to find the
things
slope.
like that.
Okay, so to find the slope, incidentally, Takesha, on the nursing exam, you say?
Yep.
That's good for the kids to hear, the little eighth graders to hear that. Because actually, even in advanced accounting, you open up a big calculus book, it'll be slope. In a big calculus book. So this, okay, now, so this is our table. To find the slope happens to be this, young lady. They say the change in, this symbol means the change in y over the change in x. Okay? And y is rise, and x is run. The y-axis is up and down, and run is this way. Okay? So in this case, what would it be? It'd be y. What's y? We could pick any y we want, any one. We could pick this one, 350 divided by 30. And guess what that's going to equal? Wait a second. 50. Wait a second. Oh, yeah. The change in y over the change in x. So what's the change in y?
10, is it 10?
10. So, I'm sorry, the change is not 350. Look at the mistakes I'm making. The change is 100, right? So in other words, 100, the change in y is 100. The change in x is 10, you see. True?
Right.
That means the slope is 10. And here's another thing. When they use the phrase rate, that means the same as slope. Because that's how we find the rate. What is the rate? Y divided by x. Okay, kids? And that's a fast lesson for the kids, I know, but you have to catch it and go to YouTube, turn it back, they can turn it back. One more thing before we go to our accounting lesson for this young lady, Takesha. Let's do one more in the B problem. Now that's what we learned so far. Now Takesha, something else can happen, Takesha. That time the slope was normal. The slope was going in a normal way. Normal is this way. That's how we read. The reason they do it that way is because that's how people read from left to right. And that's why the quadrant is, this is the number one quadrant, because most stuff is here. Now, there's 4 other quadrants. But generally, most of the stuff is here. Like in that case, money received. Let's look at this one here. B problem on page, same problem, 3.2. Now here, this is the other thing we want to learn is, this is kind of a reverse thing. What happened is this. They say that there is what happened is this, Takesha. They get a bonus card with 100 points that they can get 6 points for one ride. One ride is 6 points. And it says that, there's a bonus, copy and complete to the table, bonus. Pay close attention. Okay, so I'm trying to figure this out. Okay, I think what you're saying is this table, they're saying on this table, it's not confusing, but it says the number of rides. Take a look at this, Takesha.
Which one?
See this table? For instance, it says here that they get bonus points, 100 points. Read that B.
Okay, B. Admission to Wild World includes a bonus card with 100 points that can be spent on rides. Rides cost 6 points each.
Right. So let's go X and Y here. First, to make a table. If you're ever stuck, think about it. Now, for example, then it becomes, well, what's X and what's Y? Well, let's see. The number of, apparently what they're doing is, the way that table is, if I have 100 points and no rides, so they're saying 100 points means I've used no rides.
Right.
So it seems to me, if I've used no rides, I have 100 points.
Right.
So this is the total points. This is the total points here. And if I use one ride, how many points do I have left?
94.
94. And if I use 2 rides, how many do I have left?
is, I think it's 86?
88.
88, okay.
It's reducing by 6. If I use 3 rides, how many do I have left?
82.
82. Okay, so you see it's going by 6s. Now, this is a decreasing slope, so it's going to cause something semi-funny on the table, on the graph, which is, what we have to ask ourselves now is that the amount of points here will be, it's a little confusing. How can I make a formula now is the question. Well, what equals 94? What equals 94? How did it get to 94? Something times 1 minus the beginning amount. In other words, what I'm trying to say to Keisha is, to put it in so many words, I don't know if this will help the kids or not, but can you still see down here, Keisha?
Yeah, you can make the graph, I'll
You can
understand.
see down here? Look, if I have 94, how did it get to 94? That's what we say to ourselves. How did it get to 94? I started with 100, right? And I subtracted. What did I subtract? I subtracted 6. Where did I get 6 from? I got 6 from the number of rides, 1, you see. So, 1 what? 1 ride. What's 100? 100 is points, actually. So 1 is rides, 6 is points in this case. So, because look, if it's 2, suppose I do 2 rides. 100, now negative 6 times 2 is negative 12. So 100 minus negative 12 is, of all things, 88. So I've now convinced myself that this is the right formula. This is your graph, this is your formula. Let's make a better formula, a more official formula. It seems to be 100. It'll become like this. Y equals 100 minus 6 points times x. You see. And so then after we do that, we can replace x and y with words, with better words. So y is actually the points left. Points left equal 100 minus 6 times what? 6 times
X.
6 times Oh, 6 times what? 6 times the number of rides. So we can call R, for instance. So we could call, for example, you could call P equals 100, meaning points. You have to put down somewhere that P stands for points, so nobody would know actually. 100 minus 6 times R would be an official type of a... Does that make sense to you? So now we graph this one. Let's graph this one. What's our time on that?
8 minutes and 20 seconds.
Okay, we're just going to go right back here in a second.